Hello everyone, I'm Gauri Krishna. I'm a BTech third year student in CSC at Karunya University. So today we will see the third experiment in MLT lab, which is linear regression, multiple linear regression, and logistic regression. So we'll see the codes. So yeah, okay. So this is the first one. Okay, linear regression. So here first, we have imported all the libraries. We have used Pandas, NumPy, and Matplotlib. Here, Pandas have used to handle the dataset, and NumPy is used for the mathematical calculations, and Matplotlib is used for plotting the graphs. And we have read the data set, which is wine regression.csv. We are using the dataset wine regression.csv, and then we'll check for the we've load the data set and we'll check for the data cleaning part, and here we'll clean the data by using uh, this. Here we have given we'll check the missing values, and for fixed acidity and volatile acidity, then dot is null. We'll check the missing values here. If missing values exist, mean they are replaced using the mean imputation. So this is the first part, and mean imputation. Here the mean imputation um, helps for the data set to keep the data set like complete. That's why we are using the mean imputation here. And then here, and also we selected the variables alcohol for x, and for y value we have chosen quality, and x equal to df alcohol dot values and y equal to df quality dot values. And then we calculate here alcohol and quality, and then we'll calculate for fill the missing values only for numeric columns. Here we'll fill all the missing values, and then we'll compute the regression using b naught and b1. We'll calculate the regression coefficients. B naught is the intercept and b1 is the slope. So the equation for b1 is summation of x minus x bar into y minus y bar divided by sum of x minus x bar the whole square, and for b naught is y bar minus b1 x bar. So this is the equation we have used here, and then we'll compute the regression line. These coefficients define the regression line, and step 5 is the regression equation, and the prediction equation becomes y equal to b naught plus b1 x, and here the y pred is equal to b naught plus b b naught plus b1 star x. So this is a y pred value. This gives the predicted wine quality here. And the sixth question is to calculate the sum of squared error. So for calculating sum of squared error, the equation is sum of y minus y pred the whole square. So here we have given the line SSE equal to NP dot sum of y minus y pred the whole square, this equation. So this measures the prediction error. And the step question 7 is to calculate the root mean square value. So here we'll find the root mean square value by using the equation np dot square root of the SSE divided by length of y. So here, this is the lower root mean square. It means better model performance. Lower root mean square means it will perform. The model will be better. The performance of the model will be better. So that's it. And the eighth one is to calculate the coefficient of determination, R square value. To calculate the R square measures, this R square we have used finding the model accuracy. And this R square is equal to 1 minus the SSE divided by SST. We have used the equation here. So values will be close to 1. It means better prediction. 1 means better prediction. And the ninth one is plotting a graph, plot regression line along with the given data points. So here we visualize the data and plot dot scatter x comma y and the plot dot plot x comma y point. So here points means the actual data and the line means the regression prediction. So it will give a map, sorry, a graph like this. Quality and alcohol. Quality in y-axis, alcohol, it is in x-axis. So the tenth one is prediction. Prediction means we predict the quality for new alcohol value. Here, for example, x new equal to 10 and y new equal to b naught plus b1 into x new. So here, this gives the predicted wine quality. So this is the first part question, and we'll move to the next second part. Yeah, this is the second one, which is multiple linear regression. So here also, first we have imported all the libraries and then read data set again, and we have printed almost 10 rows. And the features here, um, this program. So here this will predict the wine quality using two features instead of one. In multiple linear, we are using two features. In single linear regression, we have used only one feature, but here we'll use two, which is alcohol and sulfates, and the target value is quality. So first one, we will load the data set and we'll handle the missing values, and here we'll select the variables, which is alcohol, sulfates, and then for the dependent variable, it is quality. And here x equal to df alcohol sulfates dot value and y equal to df quality. So this will be the dependent and independent variable here. And step 4 will calculate the normal equation. So here we will compute the coefficients using the normal equation, which is theta, using theta value, theta equal to x raised to t x raised to tx raised to minus 1 and x raised to t y. So first we add the bias column, which is xb equal to np dot c, np dot 1s, and then compute the theta value. So this will give the B naught, B1, and B2 values. B naught means the intercept, B1 is the alcohol coefficient, B2 is the sulfate coefficient. So here in Q5, question 5, we'll formulate the prediction equation, which is y equal to B naught plus B1 x1 plus B2 x2. So here y pred is equal to x B naught plus B1. Y pred is equal to xb theta. So here we'll calculate this, and then in next question, sixth question, we'll calculate the error. It is basically error calculation, SSC. So here we have given the equation SSC is equal to np dot sum y minus y pred raised to 2. This will predict the error. And in question 7, we'll calculate the root mean square error. So root mean square error is equal to np dot sqrt SSC divided by length of y. And the eighth question is for calculating the R square value. It measures the model's accuracy. So then here we'll predict in ninth question, it's the prediction basically. We'll predict the values. For example, alcohol is equal to 10 and sulfate is equal to 0.6. So then x nu equal to np dot array and x nu is equal to x nu theta. So the model predicts the wine quality. So yeah, that's it. That's all about the multiple linear equation. And the third one is the logistic regression. So logistic regression means it is used for the classification problems. So in this program, we classify the wine type using the logistic regression. So step one, as usual, we'll import all the libraries and we'll read the data set, load the data set, and then it is data pre-processing. Data pre-processing, and here will the missing values are filled using mean. So here the df numeric calls equal to df numeric this and all. The target columns type is here it is encoded, and the df type is equal to df type dot as type. So this line will convert the categories into numbers. And here we'll define the features and the target. So here all columns except the type. So the target is type. So here x equal to df dot drop type x is equal to 1 dot value, y equal to df type dot values ratio. So here it will choose the independent variable and selected variable. It will print like that. And in question 4, will it is feature scaling basically. So features are normalized here where x equal to x minus mean bar standard deviation. So here the bias column is added. X equal to np dot c, np dot ones x dot shape here. This was used for feature scaling. And then fifth question, it is a sigmoid function, which is the logistic regression uses the sigmoid activation, which is this is the equation we have used. The def sigmoid set return one by one plus np dot x exp. This converts the value into probabilities between 0 and 1. In cost function, the cost function measures the prediction error, and the goal is to minimize the cost. And in gradient descent, the weights are updated iteratively. Basically, alpha means the learning rate, and iterations are the number of training steps. So the cost values are stored to visualize the training. And in here, we'll plot the graph for the iteration, plot cost was iteration, and here the plot cost this shows that cost decreasing during the training part. So here we can see the cost is decreasing, and this is the graph cost reduction using gradient descent. And then last one, it is used for finding the model accuracy. So here the predictions are made. Basically, predictions is equal to sigmoid x theta, which is greater than 0.5. It here the accuracy is calculated, and accuracy equal to np dot mean predictions. Here this line will show how well the model classifies the wine time. So basically, this is all about the logistic regression. So in all these three parts, we saw the linear regression, multiple linear regression, and logistic regression, and we have performed the data pre-processing, calculated model parameters, and we have evaluated the performance of using the SCC root mean square error and R square, and we have visualized the results using the graph. So yeah, that's all about the third experiment in MLT. Thank you so much. Thank you.